Welcome students to GDC classes, and today we are going to see about a tablet part 3 under pharmaceutics. Now let's see what are the contents that we are going to see about tablets. So today we are going to see about the tablet manufacturing, means what are the different types of granulation techniques like direct compression, dry compression, wet granulation, and some evaluation parameters of the tablet. So these are the points we are going to cover in today's class. So let's start with tablet manufacturing. So under tablet manufacturing, the important one is the formation of granules. The important one is the formation of granules. So the granulation process may be defined as a process where small particles adhere together by forming bonds between them. Now powder form is there and the granule. Granule means slightly bigger particles as compared to powder. That means the particles are forming some interaction, some bonds, and they're coming close together, so resulting in the formation of large aggregates. That is nothing but granules. So generally, if your drug is not having some good flow property, then we are converting into granules. The granules, they are circular in shape, spherical in shape, they will have a good flow property. So that is the reason generally we are using granules. So the manufacture of granules for tablet compression may follow one or more combination of the methods. So the methods are direct compression, like without any formation of granules, direct compression, compression granulation, and wet granulation. This is also known as dry granulation method, the compression one. So these three methods we are going to see in depth in today's class. Now next see like in what cases which method is suitable. For example, if drug is having good flow properties, its compressibility is also good, the dose is high, and excipient concentration is also low. Because of higher dose, it may not require diluent. So in that case, we can directly go for direct compression methods because its flow is good, its compressibility is also good. The drug is having good flow property, good compressibility, then we can go for direct compression. For example, the flow is good but it is not compressible, then we can convert into granules. The granules have good compressibility, so we can go for wet granulation. Next is, for example, irrespective of the drug flow properties or irrespective of drug compressibility, whether it is good or bad, that if the dose is low and the excipients are high, then also we can go for direct compression method. Now if it is not having good flow property but its compressibility is good, then we can go for dry granulation. We are going to see in depth about these methods. For example, both are bad, like poor flow properties, poor compressibility also, then no matter what is the dose and what is the excipient concentration, we have to choose for wet granulation. Now next see direct compression method. Now next is direct compression. The first one is direct compression method. So the direct compression is a dry process. Direct compression is a dry process. No liquid we are adding into this one. In the powdered material in the tablet formulation is compressed directly into the tablets without the physical nature of the former being modified. Means we are not modifying any physical nature of the powder, directly we are compressing into the tablet one. So that is nothing but direct compression. The examples are formation of ascorbic acid. Ascorbic acid is nothing but vitamin C, so which is water soluble. So remember, water soluble vitamins and oil soluble vitamins. So oil solubles are like A, D, E and K. So these are oil solubles, whereas the other vitamins are water soluble. So ascorbic acid, that is vitamin C. So formulation of ascorbic acid tablets, then formulation of chewable antacid tablets. So these are prepared by using direct compression methods because their drug properties, now in this case ascorbic acid, so it helps in the process of direct compression. Next is what are the steps in direct compression. So the step 1 is grinding. Whichever is the procedure, first you have to make the uniform size of the drug. So drug is added to the granulator and it is grinded, so to have the uniform smaller particle size. Next is blending or mixing the suitable adjuvants. For example, we have seen some directly compressible vehicles are there, diluents are there, MCC, that is microcrystalline cellulose. So some other excipients whichever required, but those excipients should have the property of direct compression. So they are added into the drug molecule and that is blended and mixed thoroughly. That is added into the drug molecule, blended and mixed thoroughly. Next is tablet press. Step 3 is nothing but tablet press. So the blended powdered material is compressed by machine tooling, dies and punches of a tablet. So B tooling, BB tooling. So there are different toolings which are used for compression. Now there are advantages of direct compression as well as some disadvantages. Disadvantages are like the difference in particle size and the bulk density. If bulk density is more and particle size is less, like this, if difference is there, then that may lead to stratification within the granules. Whatever the compression is there, that may lead to stratification. It will not be easily compressible. Next is a large dose drug. A large dose drug may present problems within direct compression if it is not easily compressible by itself. For example, if the dose of the drug is very high, 650, 700, 800 mg like that, then you cannot add more ingredients into that because the tablet weight will increase. So in that case, drug has to be itself compressible without adding much of the other excipient. So large dose may create a problem. In some instance, the direct compression diluent may interact with the drug. For example, certain excipients are there. For example, we have seen for spray dried lactose. So spray dried lactose may interact with the amine containing drug and this may lead to yellow discoloration of the tablet. So in some instance, the direct compression diluent like spray dried lactose, it interacts with the drug. It may interact with the drug. The example is the same. The amine compounds, the interaction between the amine compounds and the spray dried lactose as evidenced by the yellow discoloration. So that may lead to some incompatibility between the diluent and the drug. So these are some of the disadvantages. And the next one is the because of the dry nature of direct compression, static charge buildup between the drug particles, and it can occur on the drug during routine screening and mixing, which may prevent a uniform distribution of the drug in the granulation. So because of this static charge buildup, uniform distribution may not occur. So these are some of the disadvantages of direct compression. Next is dry or compression granulation method. So see, the process of dry granulation. The process of dry granulation is also called double compression. Remember the alternative names. Wherever these alternative names comes, remember the names. So the process of dry granulation is also called double compression or compression granulation. It is also called compression granulation, or it is also known as pre-compression. It is also known as pre-compression. Remember, double compression is same as compression granulation or pre-compression granulation. So the process involves the formation of a tablet by first converting the tablet formulation into slugs. So basically the slugs are nothing but the bigger tablets only. About 1 inch diameter. It will have about 1 inch of diameter. A bigger tablets it will be there. So initially we are compressing into bigger tablets. That is nothing but slugging. This is known as slug. Afterwards, what happens? The molecule will little bit come together. Afterwards, we have to break that tablet. That is deslugging. Slugging and deslugging. Now, deslugging will have a nature of granule. So slugging and deslugging. Slugging means a compact mass, and that is also punched using compression machine. The punches only, the slugging takes place, after which the tablets are broken down into slug. Then you have to pass this to certain sieves to get the uniform size. So that's how the granulation of this using dry compression takes place. So the process first involves the formation of a tablets by first converting the tablet formulation into slug or compact mass, that is known as slug, or it is also known as compact mass. These form masses are screened. Screened means they are passed through the sieves to form uniform sized fine granules. To form uniform sized fine granules, it is also known as deslugging. So the technique is suitable for those drugs which are moisture sensitive, means in that cases we cannot go for wet granulation, we cannot go for any other solvents. For example, the other one is if the drug degrades at higher temperature and administered in higher doses. So the technique is suitable for these kinds of drug molecules. Next is this is the slugging and deslugging. The technique of dry granulation of a powdered material can be accomplished by two methods. So slugging, that is a slug formation. So this is known as slugging. And next is roller compactor, in which the masses are formed. Now what are the steps? Step 1, as I said, drug has to be grinded in the granulator. So drug is added to the granulator and grinded. Step 2 is blending or mixing. Step 2 is blending or mixing. So suitable excipients like diluents and other excipients are added and mixed in a blender. So they are added and mixed in the blender. Next is compaction. After mixing, the powder mixture is slugged, means they are formed into a compact mass. So they are compressed into large flat tablets or pellets about 1 inch in diameter, 1/3 of your fingers. So that much big tablets they are forming. On large scale, roller compactor is preferred. So when you have to do a larger batch size, then roller compactor is preferred. Afterwards, we have to deslug those tablets. We have to break those tablets. So these slugs are broken down by hands, means if it is a laboratory method, then by hands, or by milling. On a large scale, milling is done, in which the powders, the tablet which is formed, that is broken down into powder or to granules. Step 5 is screening. To form a uniform size, the screening is done, or it is also known as sifting. Means we have to pass that deslugged granules from the sieves. So the granules undergo dry screening through a desired mesh for sizing. Step 6 is blending or mixing. Step 6 is blending or mixing. So the lubricating agent is added and mixed thoroughly in a blender. So the lubricating agent is added and mixed thoroughly in a blender. Step 7 is a tablet press. Afterwards, we have to add some lubricating agents and mix, and then it is compressed into a final tablets. Now these tablets will have a normal size and shape. So the resultant granules are compressed by machine tooling, that is dies and punches of tablet press. So this was about dry compression. The examples are acetyl salicylic acid tablet, that is aspirin. This is aspirin, and formulation of vitamin B complex tablets. So this is about the dry compression. Next, third method is wet granulation method. Third method is wet granulation. So the wet granulation, because we are using liquid, it is known as moist granulation, is the most conventional, versatile and widely used technique for the manufacture of compressed tablets. So most widely this method is used as it imparts all the physical properties to the granules. So this technique differs from the other granulation method because it involves the usage of liquids to form the compact mass. So how the mass will form? If you are adding some liquid, some binder solution will be there, some liquid will be there, then these molecules will come closer. So that will give a compact mass. So the examples are formulation of acetaminophen tablets. Remember acetaminophen tablets. And the another example is aluminium hydroxide chewable tablets. Aluminium hydroxide chewable tablets. Now next, see what are the steps involved. The first is grinding. So the drug is added to the granulator and it is grinded. Blending or mixing. Again, we have to mix with the suitable diluent or other excipients and added and mixed in a blender. Step 3 is shear mixing. Granulating liquid. Example, alcohols are added to form a damp mass. Certain alcohols will be added to the mixture of diluents and other excipients with the drug, and a damp mass will be formed. A damp mass will be formed of the powdered material which resembles agglomerates. It will form like a agglomerates. It will resemble like agglomerates. Step 4 is wet screening. The damp mass will be screened, means it will be passed and it will form the pellets or granules. The damp mass will be passed through the screen or from the mesh to form the pellets or the granules. Afterwards, we have to dry the granules. So the pellets or the granules are dried to remove any of the excess of the liquid. Then again we have to pass the dry material through the mesh, and which will result in the size reduction. If you are passing the material or the granules through the sieves, then it results in the size reduction. Step 7 is blending. So after, at the end of the step, we have to add lubricating agents like magnesium stearate and all, and the mixture is mixed thoroughly. Once lubricating agent is added, then we have to mix it thoroughly in a blender, and afterwards the final compression takes place. So the resultant granules are compressed by machine tooling of a tablet press. So this was about the wet granulation. Now see, there are various stages in the development of a formation. Now see, the surface tension and the negative capillary. So basically just remember which is the first stage, second, third, fourth. So first is pendular. We'll see what is pendular, funicular, capillary and droplet. So first, see the surface tension and the negative capillary pressure in the bridges. So these are the molecules in which this is the formation of wet granulation. Okay, these are the particles. So first is surface tension and the negative capillary pressure in the bridges provide cohesive force. Cohesive force is nothing but force of attraction between similar molecules. Now in the process of granulation, we want the particles to come together. That means they should have sufficient cohesive force. They should have sufficient cohesive force, and it result in a condition. The first one is a pendular condition. So here you can see it is a pendular state which has comparatively low mechanical strength, because just now it has started. So it has started the formation of that droplet. So it will have comparatively low mechanical strength. So as the liquid content increases, as you will add more and more liquid or the volatile solvent, any alcohol into that one, the several bridges make coils. Coils means they will form agglomerates. Several bridges. Now here you can see, here it is a single bridge. Here it is a single bridge. This is a single bridge. Now what happens? This bridge and this bridge will come closer. So like this structure will form. Between two particles, a single bridge will form. If you add more liquid, then several bridges will come closer to each other. That will form a coalescence. And that second stage is known as funicular state. That second stage is known as funicular state. This is known as funicular state. Okay. So as the liquid content increases, several bridges may coalesce, giving rise to the funicular state, and a further modest increase in the strength of the moist granules. Little bit strength will increase because of the coalescence. Bonding is affected by interfacial forces at the granule surface and by the negative capillary pressure throughout the interior liquid filled space, and this is known as a capillary state. So third, you can see a boundary will create between the end of the particle. So that is nothing but a capillary state. This is nothing but a capillary state. Further addition will form a droplet formation. More liquid if you add, perfect agglomerate of a droplet will be created, and this is nothing but stages in the development of wet granulation. So remember, pendular, funicular, capillary, and then droplet. So these are the 4 stages and the sequence of that. Now next we are going to see is important, that is evaluation of tablets. So generally whenever a tablet formulation takes place, we have to evaluate it for its appearance. So how the tablet looks, what is the color, is there any odor, anything. So that is the general appearance. Then size and shape, that is important, whether it is round, oval, oblong, what is the size, because if size is bigger, patient should not have difficulty in swallowing. So size and shape. Unique identification marking, organoleptic properties, what is the hardness of the tablet, how it is measured, friability, what should be the limit of friability, what should be the drug content and the release, weight variation, content uniformity, disintegration, and dissolution. So these are the parameters that has to be evaluated in case of tablets. So first see size and shape. So general appearance, that will be done by visual observation only. So it is measured by micrometer. So it is measured by micrometer. Remember, size and shape, it is measured by micrometer. This is the diagram of that micrometer. So this is the anvil, this is the spindle. In between this measuring faces, in between this the tablet will be placed, and from here you will identify. This is a circular scale and this is the main scale. So from here you will identify, this is a vernier graduation. So apart from micrometer, vernier caliper scale can also be used. This is a thimble, this is a U frame. So see, it is measured by a micrometer, or placing patent tablets in a holding tray where their total crown thickness may be measured with a sliding caliper scale. So tablet thickness should be controlled within plus minus 5% variation of a standard value. So whatever the 5% variation is there of a standard one, that has to be maintained. For example, if your tablet is 20 mm, so if the standard is 20 mm, then size, then diameter, then it has to be controlled within 20 plus minus 5%, within that range only. Next is hardness. This is nothing but tablet crushing strength. What is the hardness of the tablet? Because there is a link between hardness and the disintegration. Greater the hardness, lesser will be the disintegration, and that is the reason it is important to evaluate the hardness of the tablet. So there are various instruments. So force required to break a tablet in a diametric compression test. For example, if it is a circular, then from a center only it has to be broken down. For example, if it is like this, then it has to be broken down in the vertical direction, like these 2 pieces from here. So like this, there has to be certain parameters. So what are the different instruments? Monsanto tester, Strongkopf tester, Pfizer tester, 𝘿𝙂𝙎 tester, and Schelunzer tester. So these are the different instruments for hardness testing. Next is friability. Now very important, this one. So for friability is important, it's official in the USP. Which test is official in the USP? So friability is official in the USP. Laboratory friability tester, so that is known as Roche friability. That is known as Roche friability. So this is the instrument. So internal diameter is 283 to 291 nanometer. Now this is the, they are talking about this diameter, the circular one. So basically, and depth between 36 and 40 mm, that revolves at 25 plus minus 1 rpm. So basically it depends upon what is the weight of the tablet. So basically you have to take total weight, that is 6.5 gram, depending upon what is the weight of your tablet. If it is 650 mg, then you will take the 10 tablets like that. So total weight, it should be 650 gram. Sorry, 6.5 gram. So the total, that much amount of the tablets you have to take. So 6.5 gram tablets we have to take. Then we have to take the initial weight of the tablet. We have to take the initial weight. So W0 will be the initial weight of the tablet. For example, it is 100. 100 is the initial weight. If we are taking 6.5 gram, it will be exactly if we take, it will be 6.5 gram. That is the initial weight of those tablets. Then what we have to do? We have to subject this to friability testing. We have to place the tablet inside this. It will keep revolving at the RPM of 25 plus minus 5 25 plus minus 1 RPM. So the tablets, as it goes here, it will fall down. As it goes here, it will fall down. So at each rotation, it will go up, it will fall down. It will go up, it will fall down, like that. So because of which there will be certain loss in the tablet. There will be certain, some tablets will break if hardness is not proper. So after the completion, and it will be for 4 minutes. This time is for the 4 minutes. That means it will be 100 RPM. So for the 100 RPM, we have to test the tablets. Afterwards, after doing that, we have to take the W1, that is the final weight. Final weight will be approximately something like 6.499 or 6.5 also if it is not doing, but less than this one only. Okay, so what we have to do? We have to put the values in the formula, that is 100 into 1 minus W0. W0 is the initial weight of those tablets and W is the final weight of the tablet. W0 is the initial weight, W is the final weight of the tablet, and we have to substitute in the formula and we have to calculate the value of F. F is nothing but percent friability. F is nothing but the percent friability. So percent friability should be less than 1%. So maximum weight loss from the 3 samples of not more than 1% is generally acceptable for conventional compressed tablets. So generally it should be 1%. For example, it is 6.5 gram, that is 6500. So the 1%, it will be 65 mg. So it should not cross, the percent loss should not cross 65 mg after subjecting to friability. So it should be less than 1%. That means friability is generally done for like shipping test and all, like during transportation the tablets are stable, it should not be broken down. For that reason we have to do the friability test. Next is drug content. So uniformity can be demonstrated by either of the two methods. So it can be weight variation and it can be content uniformity. So the tablet should not vary from tablet to tablet and in terms of weight, and it should have a same content. For example, if it is 500 mg paracetamol, then all of the tablets should contain 500 mg of paracetamol. So let's see what is the test for weight variation. So weight variation, 20 tablets. It is not like one tablet is having 500 mg weight, other is having 600 mg. No, the variation should be less. So for that reason, randomly we have to take 20 tablets. So they are taken and we have to weigh them individually, one by one. Like that 20 weights we have to take. Then we have to take the average weight of those tablets. Average weight is calculated. The individual weight, now individual weight we have to compare with the average weight. Not more than 2 of the tablets. Once calculating the average weight, not more than 2 of the tablets must differ from the average weight by not more than percentage stated in the table. So it should not vary. I will tell you about the percent. So see here, this is the percent difference. This is according to USP, according to IP is also there. So this is according to USP. So the average weight and the individual weight should not be more variable than this difference. The difference should be less than this one. Now it depends upon what is the tablet weight. For example, the tablet weight is 130 mg or less. For example, tablet weight is 130 mg or less, then the difference should be less than 10%. Difference between the average and the individual. Difference between the average and the individual should be less than 10% if the tablet weight is 130 mg or less. If it is 130 to 324, if your tablet weight is 130 to 324, then the percent difference should be less than 7.5%. the percent difference should be less than 7.5%. If your tablet weight is more than 324 mg, if your tablet weight is more than 324 mg, then the difference between individual and the average weight should not be more than 5%. Should not be more than 5%. Similar is for the IP or BP, weight variation according to IP/BP. The only difference is about the weight of the tablets. The only difference is about the weight of the tablets. For example, the average weight is 80 mg or less. For example, the tablet weight is 80 mg or less, then the percent difference should be less than 10%. For example, the tablet weight is 80 to 250 mg. The tablet weight is 80 to 250 mg, then the percent difference should be less than 7.5%. And if it is more than 250 mg, then the percent difference between individual and the average tablet should be less than 5%. So the percent difference is same for USP and IP/BP. The only difference is about their weight. Here it is 130, here it is 80, and the highest is 324, here it is 250. So this is the difference between USP and IP/BP. So that was about the weight variation test. Now let's see about the content uniformity. Let's see about the content uniformity. For all coated and uncoated tablets and all capsules containing 50 mg or smaller sizes. For all, this applies to all coated, uncoated, and the capsules also who have 50 mg or smaller size. So initially for weight variation we have taken 20 tablets. Now for content uniformity we are taking 30 tablets. So 30 tablets are first selected, out of which we have to check the assay. Assay is nothing but checking the amount of drug present. Out of which 10 we will assay. Out of 30, 10 are assayed individually. Out of 10, 9 must be within the limit of plus minus 15%. Out of that 10, 9 must be within the limit of 15% of the declared potency, and no tablet out of this 10, no tablet should exceed 25% difference. All the 10 tablets should be within plus minus 25%, and at least 9 tablets should be between plus minus 15%. So this was about the content uniformity. Next is about the disintegration test. So the time required, disintegration, whenever a patient will take the tablets, take the tablets, it first has to disintegrate, and then the dissolution process takes place. So how much time it is taking for a given set of conditions to disintegrate into particles, and that will pass through 10 mesh screen. So this is a disintegration apparatus. So these are the 6, like first of all 6 holes are there from where we will put the tablets. Here it will be the media 1 liter, and at the bottom of this one handle, the 10 mesh screen will be there. So the particles, the disintegrated particles will pass through that mesh. So the disintegration test is carried out using the disintegration tester, which consists of a basket rack and holding 6 plastic tubes. So these are the plastic tubes here, open at the top and bottom. The bottom of the tube is covered by, so these are the plastic tubes, and this is open from the top because to add the tablet, and it is open from the bottom because the disintegrated particles will come down. So it is covered by bottom, it is covered by 10 mesh screen. So the basket is immersed in a bath of a suitable liquid which is held at 37 degrees Celsius in a 1 liter beaker. So this is a beaker. This is a water bath. This will maintain the temperature of 37 degrees Celsius, and the beaker is 1 liter. For compressed and uncoated tablet, the testing fluid is usually water at 37 degrees Celsius, but instead of water, simulated gastric fluid may also be used. See, if 1 or 2 tablets fail to disintegrate out of those 12, if 1 or 2 fails to disintegrate, then the test is repeated using 12 tablets. The test is repeated using 12 tablets. For most uncoated tablets, the BP requires that the tablet disintegrate in 15 minutes. According to British Pharmacopoeia, the tablet should it is requirement that the tablet should disintegrate in 15 minutes. Although it varies for some uncoated tablets. It may vary for uncoated tablets, while for coated tablets up to 2 hours may be required because the coating is there. So depending upon the coating, the 2 hours may require for the disintegration. Now see, this is very important. For uncoated, 15 minutes is the limit. For the film and sugar coated tablet, 60 minutes. For the enteric coated tablet, 3 hours, because 2 hours in the gastrointestinal tract, means in the acidic stomach, and then in the intestine. So 3 hours enteric coated. Hard gelatin capsule, 30 minutes. Soft gelatin capsule, 60 minutes. So this was about the disintegration. Next and the last one is about the dissolution one. So the dissolution. So dissolution may be defined as after disintegration, the drug particles has to be dissolved in the gastrointestinal fluid. So it may be defined as the amount of drug substance that goes into the solution per unit time. Under standardized conditions of liquid solid interface, temperature, solvent composition. So how much amount of the drug is going inside the dissolution media or in the gastrointestinal fluid, that is measured. So at least 75% of the drug should get dissolved in 45 minutes. So at least 75% of the drug should get dissolved in 45 minutes. So that is the limitation for the dissolution. Now see here, USP type 1. What is the USP type 1? So that is a basket one. USP type 2. So that is a paddle one. Depending upon the type of dosage form, these apparatus are used. USP type 3 is a reciprocating cylinder. USP type 3 is reciprocating cylinder, and USP type 4 is flow through cell. So you can remember as F for 4 and F for flow through cell. So this is USP type 4. So thank you. So this was all about the tablet evaluation parameters, and next part we'll see in the next session. Thank you.